In this problem, we're asked to find values of k so that cosine of kx equals 0.5 has exactly 3 solutions in the range from 0 to 360 degrees. Before we start this problem, what's important for us to understand is how the solutions to this problem actually look. So first of all, let's draw a cosine graph from 0 to 360, or maybe a bit further, and think about when it equals 0.5. So we should start like this. So this is our x, this is our y. And we know that a cosine graph starts at 1. It goes down to meet the x-axis at 90 degrees, goes all the way down to -1, back up, and that would be 360. But we're going to repeat this graph just a bit further. Could go to about here, and this would be 720 degrees. What we'd like to think about then is, when does this graph cosine of x equal 0.5? And because the maximum amplitude is 1, 0.5 is going to be about here. And thinking of our solutions then, we've got 1, 2, 3, 4, like so. Obviously we could keep going if we wanted to, but we don't need to go any further. The first solution we could find on our calculator just by typing in cos -1, or inverse cosine of 0.5, because that's the height here, 0.5. So cosine -1 of 0.5, that should give us 60 degrees. So that first solution, that's the number 1 solution, 60 degrees. From there, we're thinking about properties of the cosine graph. What we know is that this solution is equally spaced from 0 as this one is. This would be 360 degrees. So this must be at 300 here. In other words, our cosine graph is symmetrical, about 180 degrees. We can then find a second set of solutions by adding on 360 to each of our previous ones. So 60 add 360 should get us 420, and then 300 add 360 should get us 660 degrees. That's enough for now then. We've just thought about y equals cosine of x for this graph. Now we'd like to think about what this k does. And when we add this k in here, it tells us that we're stretching or compressing our graph. The bigger that k is, so as k grows larger, the more compressed our graph gets. Let's think then about 2 cases which are going to be the extreme ends of our 3 solutions. So we could call this case number 1. Oh, if my chalk will write a bit nicer. And case number 1 happens when we just about have 3 solutions. The third solution, this would be number 1, this would be number 2, this would be number 3. The third solution just about squeezes into 360 degrees. So if we imagine the shape of our graph, this is our cosine x graph. It's going to look something like this. And this here is 360 degrees. What we've got is our third solution just creeping into that range at 360. So this is it represents 0.5, which is where our solutions are located, 1, 2, and 3. What we need to think about then is that before, this solution was located at 420 degrees. And thanks to our stretch or compression, it's just about made it to 360. So what that's telling us is our compression, our stretch or compression factor, has sent 420 has just about gone to 360. Make that a little bit nicer. 420 has just about gone to 360. So we need to think, well, what is that multiplied by? And it's a factor of 6/7, isn't it? 360 is 6/7 of 420. So this scale factor here would be times 6/7. And because things are inverted when we're thinking of stretch or compressions on the x-axis, that would mean k for this graph would have to be 7/6. We take the reciprocal of that times 6/7. What that's telling us then, this is a key value for k. When k is 7/6, we just about get our 3 solutions. That's going to be the smallest value of k that we're allowed then. Let's think next about the largest possible value of k that we're allowed. So for case number 2, we're going to draw a similar graph. But whereas here our third solution just about appeared, we'd like to think of the other end. And that's where our fourth solution doesn't quite appear. So this is where we have 3, we're really happy we've got 3, but 4 doesn't quite work. So let's draw our graph again and imagine what it looks like. See, cos has to start here. So we'd have one solution, this would be solution number 2, this would be number 3, and number 4 would be about there. If we again draw a line on to show where 0.5 is, so this is our 0.5, we've got 1, 2, 3, and the fourth solution, let's think about the case where it just about appears, and then we'll think, well, we can't include that at the end. What we've got then is this fourth solution, which we're imagining would appear at 360 degrees. That used to be at 660 when this was just a graph of cosine of x. When it was cosine of x, we had 1, 2, 3, 4. So our k stretch or compression factor has sent 660 degrees, has been sent by some stretch or compression to just about 360. So again, we're thinking, what number have we multiplied 660 by to get 360? Well, they've both got a factor of 60, so it should be 6/11. Right, because 60 times 6 would be 360, 60 times 11 would be 660. So we've multiplied this by 6/11. And what that tells us, thinking about that compression, is that our k, again it must be inverted, our k for this would equal 11/6. These are our two important k values then, 7/6 and 11/6 for this problem. When we write out our solution, we would like k, it needs to be between 7/6 and 11/6. But we also just have to think about, do we want our inequalities to be strict, or can we include the equals in there? Well, for this first one, k is 7/6. This would be where our third solution just about would be included. But 360 degrees is not included in our original range of angles. We can't quite be 360. So what we need is k must be strictly more than 7/6. And for our 11/6, well, this would be where the fourth solution is exactly at 360. That's not a problem for us because 360 is not included. So the fourth solution at 360 is allowed. k could be 11 over 6. So we have 7 over 6 strictly less than k, but k could be equal to 11 over 6. So this is our answer that we want.